Today we have the Moivre's theorem. Basically what they're asking us to do is find the cube root of 1 plus I in polar form using the Moivre's theorem. So as you can see, they already pretty much gave us the formula. We have r to the 1 over n brackets multiplied by cosine of theta plus 2k pi divided by n plus I sine of theta plus 2k pi divided by n, close brackets. So that's our formula where n relates to the root. So what does that mean? Basically, if we're looking for the cube root, what is the cube root? Basically, the cube root, if you didn't already know, which I would expect you to know if you're watching this video, is basically just whatever integer here, n, the cube root of n. So n times n times n, n times n times n, n 3 times. Good. We have the square root, which is basically the perfect square, which just relates to this being a 2, but we have the cube root, which this relates being a 3. So in this case, n, let's forget about this, n is equal to 3 for our formula, right? So that's what that means, where n relates to the root. If we're looking for the fourth roots, then n is going to equal to 4. We're looking for the square roots, n is going to equal to 2. All right, so that's what that means. We have the formula now. So basically, let's go ahead and begin. Let's look at the formula. What do we need? We need the r value. So basically the r value, if you don't know how to find the r value, we are going to do a little refresher. So r is equal to the square root of basically a squared plus b squared. So that's going to be the r value. In this case, the r value, the a squared plus b squared, number 1 is going to equal to a, and the invisible number 1 in front of the I is going to equal to b. So just pretend there's an invisible number 1 right here in front of the I to represent that there's one positive I. All right? So we have r is equal to a squared plus b squared, the square root of that. All right, so let's go ahead and find our r. And that is going to be r. Let's write it down here. R is equal to the square root of 1 squared, remember 1 right here, plus 1 squared. Again, the invisible positive 1 in front of the I. So that you get that, and that is going to give you your r value. Any basically 1 to the second power is 1, plus 1 to the second power is 1, and the square root of 1 plus 1 is the square root of 2. And 2 is not a perfect square, so we're just going to leave it as the square root of 2. So that's our r value. We found our r value. What else do we need? We need to find our angle, our theta. So in order to find that, we use tangent. Tan of theta is equal to b over a. So our b, again, is obviously going to be our number, the invisible positive 1 in front of the I, divided by a, which is going to be the 1 right here in the a position. So that is going to be equal to tan of theta is equal to 1 over 1. 1 divided by 1 is 1. So that is what we get when we plug in our a and our b and our a value. We divide b by a, 1 divided by 1, we get 1. So now we can basically take this positive number 1 and inverse it, put it in tangent of the inverse of tan. So tan of inverse of 1 is equal to, so what, we already know that tangent is equal to y divided by x, right? So what those two values divided by each other is going to give us 1. It's going to be pi over 4, right? Pi over 4. You can find this, if you're confused as to where I found this value, you can either use a calculator. So we're going to use inverse tan of 1, which is going to give us 45 degrees, but if we turn that into radians, it's going to give us pi over 4. So basically, you should already know the unit circle by now if you're watching this video and you want to do this. But if you don't, that's okay. I'll just give you a little quick refresher. So if you don't want to see this refresher, you can just skip. But basically, this is going to be your unit circle. It's going to be a rough sketch of your unit circle. We're looking for, if you recall, tangent is sine divided by cosine, right? So we have, let's say right here, pi over 4. Pi, positive pi over, yeah, pi over 4 in the first quadrant, right? If you should already know this, but the coordinates, the x and the y for pi over 4 is the square root of 2 divided by divided by 2, and then the square root of 2 divided by 2 for the y, so x and y, right? Sine is going to be the y value, cosine is going to be the x value. You divide these two together, you're going to get 1. So basically this is looking for the angle, and the angle is going to be pi over 4. This will make a little bit more sense if you already know the unit circle, which go ahead and study the unit circle before doing this. So that's how I got pi over 4, okay? This relates to the quadrant, right? So we have a positive 1 over here and a positive 1 over here, right? So since these two values are positive, your angle is going to be in quadrant 1. If they were, let's say, x is negative and y is positive, it's going to be in quadrant 2. All right, so that's just a little quick refresher. Okay, so let's continue. So now that we found our theta, which is pi over 4, so let's write it down here, right here. Yeah, theta is equal to pi over 4. Theta is the angle, by the way. This is the angle, okay? So now we have theta is equal to pi over 4. Now we can go ahead and basically plug it into our equation that they gave, the formula they gave us, right? The Moivre's theorem. So we have our r, which is let's separate this. So let's draw a line. That's a bad line. Okay, let's separate that. So let's go ahead and plug in our r value. So the square root of 2 to the 1 divided by n. Recall that n is equal to 3 because we're looking for the cube roots. All right, so n is equal to 3. So r square root of 2 to the 1 divided by 3 power. 1 divided by 3 power. Good. Brackets cosine of cosine of the angle, which is going to be pi over 4. Pi over 4 plus 2k pi divided by n, which is going to be our 3, recall that, 3, plus the I sine of pi over 4 plus 2k pi divided by 3, close brackets. Alright, so that's how it's supposed to look like, and let's go ahead and find the cube roots. So, we want to find the cube roots. So what does that mean? We want to find W0, W1, and W2. So we want to find 3 of them. We're always going to start at 0. So W of 0, we're going to find that one. W of 1, we're going to find that one. W of 2, we're going to find that one. If you count these roots that we're going to find, there's 3 of them, which corresponds to the cube root, right? If there's a 4th root, we're going to have a W3. But remember, you always want to start at 0. 0, 1, 2, 3, 4, etc. All right? But in this case, we're doing 3. So W1 and stops at W2. All right? Good. Let's go ahead and let's solve for the first W. So W of 0. W of 0. That means we're going to replace K with 0. So, parentheses, just a little note. Replace K with 0. All right. So, before we move on, let's first solve for the square root of 2 to the 1/3 power. So let's go ahead and solve that. Let's just solve it right here. So we have the square root of 2, which is equal to basically 2 to the 1/2 power. This is just some basic algebra, nothing too crazy. Raised to the 1/3 power. So if you didn't already know, this is just some algebra stuff. When we want to basically when we have an exponent like this in parentheses, we want to multiply these two exponents to get 2 to the 1/6 power, right? Because 1 times 1 is basically 1, 3 times 2 is 6, so we have 2 to the 1/6 power. So that's going to be our r solved. All right, so let's go ahead and go back to w0 to find our first root, which is 2 to the 1/6 power. Remember, we got this by doing a little bit of algebra. And now we have, let's go ahead and, basically replace k with 0. So that is going to be, okay, so we're going to replace k with 0. So let's go ahead and see here. 2 times 0 is 0 times pi. 0 times pi is obviously going to be 0. So we're going to only be left with pi divided by 4, pi over 4, divided by 3. So remember, replace k with 0, and anything multiplied by 0 is 0. So this is just going to be one big 0. Pi over 4 plus 0 is obviously just going to be pi over 4, and now we're going to have to divide by 3. So remove the brackets, cosine of pi over 4 divided by 3 is going to be pi over 12. Pi over 12, right? Yeah, pi over 12 plus the I sine of pi over 12, because this is basically the same thing, right? Pi over 12. So that's going to be our first root. 2 to the 1/6 power cosine of pi over 12 plus I sine of pi over 12. Let's say, for example, they don't want radians. This is in radians. They want degrees. You want to convert this into degrees. That's okay. We're just going to take the pi over 12 and convert this to degrees, which we do that by multiplying 180 divided by pi, which obviously these two pi's cancel out. So now you have 180 divided by 12, which is going to give you 15 degrees, I believe. Let's confirm with the calculator. 180 divided by 12, 15 degrees. Yeah, you're gonna get 15 degrees. So if they want this in degrees, just take out the pi over 12 and just put 15 degrees in there, and that's it. So let's go ahead and that's the first root. Let's go ahead and do the second one, which is w sub 1. So we have a 1 here, so what does that mean? Basically just replace k with 1. Replace k with 1. So let's go on to our formula. Pi over 4 plus 2 times 1, which is 2, times pi, which is 2 pi, divided by 3. So pi over 4 plus 2 pi, remember, we replace the k with 1, so this is just going to be 2 pi. 2 times 1 is 2, times pi is 2 pi. So pi over 4 plus 2 pi divided by 3. So let's go ahead and just use a calculator. You can do this manually if you want, but let's just do the calculator just to go a little faster. We have pi divided by 4 plus 2 pi, remember, equals, it's going to give you that, divided by 3, which is going to give you 3 pi over 4. So our new angle is going to be 3 pi over 4. So we have, again, our 2 to the 1/6 power cosine of 3 pi over 4 plus the I sine of 3 pi over 4. So that's going to be your second root, your second answer. So you box that. And if you want to convert 3 pi over 4 into degrees, you can. You got 3 pi over 4 times 180 over pi. You cancel the pi's. You multiply across. 3 times 180 is, I don't know, let's see. 3 times 180 is that divided by 4. You get 135 degrees. 135 degrees. So if they're asking for degrees, just replace the 3 pi over 4 with 135 degrees. All right, so let's go on to our last answer, which is W2. So replace k with 2. So now let's go ahead and replace k with 2. Go back to the formula. Pi over 4 plus 2 times 2 is 4 times pi is 4 pi divided by 3. So pi over 4 plus 4 pi divided by 3. So calculator, let's go ahead and do pi divided by 4, right? Plus 4 pi is equal to that divided by 3 is equal to 17 pi over 12. So 2 to the 1/6 power cosine of 17 pi over 12. 17 pi over 12, that's a 12 by the way, plus I sine of 17 pi over 12. That's going to be your third answer, so box it. And again, if you want to convert 17 pi over 12 to degrees, you can. Remember, 17 pi over 12, you want to convert this to degrees, you multiply 180 over pi. These two will cancel out. Go ahead and cross multiply, then divide, and you should get 255 degrees, I think. Let's go ahead and confirm. So 17 times 180 divided by 12, 255 degrees. Yep. So you should get 255 degrees. So yep, that's basically finding the cube roots using of this particular problem using the Moivre's theorem. So yep, that's it, and good luck.